Hi, everybody. So I have this very dramatic title for this talk today, and it's a follow-up to a talk I was giving last year on multiple occasions, and some of the things I learned sort of talking about ethics in machine learning. My clicker is not working. All right, so yeah, I'm Evan Estola. I work at Meetup. That's how you can reach me. You guys have heard of Meetup before? Hands? All right, good. All right, cool. So most tech people have heard of Meetup, but Meetup isn't just tech groups. It's jogging groups and moms groups and knitting groups and all sorts of stuff. And we're all over the world. We have like 30 million members. Recommendations at Meetup is a very difficult problem. And that's why I have any reason to be talking to you guys today. So I've been working at Meetup and working on recommendations for a long time. And a great way to make a recommendations problem harder is to add location and or time, and we have both. So the sparsity increases insanely. We don't have this sort of constant stream of data that you might get if you're tapping into these ad networks or something like that. So our cold start problem is really intense. And obviously we're dealing with real user information and inputs, and so we have to deal with lies a lot. And so data cleaning, that sort of thing. These are all problems that we see. Has anybody ever ran into the Schenectady problem? Not just that you've heard me mention it before, you've actually seen it? Okay, so the Schenectady problem is, well, so I'll give you an example. There was a message, or there was a news story about Ashley Madison, the Ashley Madison dating site leak. And they mentioned the top 5 cities for Ashley Madison users. And I think the second or third city was Schenectady, New York, which is like a tiny town outside of Albany, upstate. And I knew immediately what they'd done because I'd ran into this problem myself. If you're using zip code data, watch out, because if you ask people what zip code they're in, some of them are just going to type 12345, which is a zip code in Schenectady, New York. So these are real data issues. So at this point, you guys know that data impacts real people, right? So it's not just the ads you see, but we're getting to a point where machine learning algorithms are deciding if you get into school, if you can get a loan. There's this crazy Orwellian, like, just machine learning algorithms deciding recidivism, and so people are getting prison sentences based on algorithms. And this is pretty wild stuff, and probably something we need to be taking very seriously and to be very careful about how we do these things. I started thinking about this problem personally because at Meetup, we recommend meetups, and I ran into this problem where we were thinking about adding features like gender into our model, and we were looking at the data, and very clearly we could see that women were less likely to join tech meetups than men were. And this is something that just didn't feel right to us. We didn't want to not recommend tech groups to Meetup because of this historical bias, and et cetera, et cetera. And so that's what really got me thinking about these problems. So my last talk was called When Recommendation Systems Go Bad. So I'd talk about things like the Amazon email that this guy bought a kitchen scale, and then Amazon sent them the drug dealer starter kit recommendations. We already heard earlier about, Claudia mentioned this, this person who discovered that black sounding names were more likely to generate these ads suggesting that this person had an arrest record. You probably heard at this point about the ads that were suggesting high-paying job training that were more likely to go to men than women. One of the ones that I think are the worst is the Google vision system that was automatically tagging pictures and tagged this African-American guy and his girlfriend as gorillas. I just can't imagine having to live in a world where the internet, is going to perpetuate these racial stereotypes. And this is obviously just a, training error that's not like they trained it on racist tagging data or anything like that. I mean, I hope, but this is still a problem, right? And a lot of the talks today have made me really think more about this, like getting training data that's not just people that look like you, or the training data that's obvious to get. For instance, if you're doing crazy deep learning, awesome stuff on detecting cancer, you're going to have a bias towards people that could afford to get the treatment and the scan that you were looking at, right? So maybe your algorithm isn't going to be as good at detecting marginalized groups, the cancer in those people. So this is like things we should all be thinking about. This is really serious stuff. This is another funny one. You guys heard of Tay.ai is this Microsoft chatbot that they set loose on Twitter, and it learned how to be like super racist and sexist because of course it did. It was Twitter data. Garbage in, garbage out, right? We all know that. So I used to end my last talk with, racist computers are a bad idea. Don't let your company invent racist computers. And I thought that was pretty reasonable. So then I spoke at MLConf Seattle last year. And so they had a rating system. You could rate. I think there's a rating system today too, but they haven't been pushing it as much. But this is what the ratings of speakers before lunch looked like. So most of them were 5-star, a lot of really great speakers. The later session was a lot worse, a lot of the sort of, I don't know if it's post-lunch hangover or some sort of selection bias or both, but so I know I'm already in trouble because I'm after lunch here today. One speaker was good enough to climb out of the after lunch hole, but there was a session right before lunch though on data ethics, and I spoke, and this awesome guy Florian spoke about an algorithm that he invented to detect bias. I think I'll talk a little bit more about it later, but the ratings for these look completely different than all the other ones. Most of them are either, there's a clear peak or they're relatively flat. These are totally bimodal, with this big peak in 1-star reviews. And this got me thinking, like, why do people hate me? Like, who are these people that either thought I was just completely uncharming or what? But the fact that the other ethics talk was the other one that had this sort of pattern, this bump in 1-star reviews, made me think that there's some pattern here. Briefly, math aside, summary statistics for multimodal distributions are really hard, so if somebody could invent something good for that, I'd really appreciate it. A lot of the statistics, you have to like tell it what the two modes are beforehand, so you already have to know how to detect them or something. It just sucks, so invent something good for that, please. Anyway, the main thing that people kept telling me after my talk, or the people that were the most sort of skeptical of my talk, it always boiled down to this same argument of, if you go out of your way to not be biased, isn't that being biased? If you go out of your way to, if you're not less likely to recommend tech groups to women, isn't that suboptimal? Aren't you doing something wrong? And that's what's really been driving my thinking for a while here is there's this idea in sort of machine learning, data science, whatever you want to call it, space, that we have to do the perfectly optimal thing. The mathematical thing is what's right. And so I wanted to question that a little bit. And I think we've heard some examples today that actually fit really well in this. So for instance, I think a lot of us have been at some point building a model, and then all of a sudden we add a new feature or add some new data into the model, and all of a sudden our model's just perfect all of a sudden, like it's really, really good, and you're like, yes, I cracked it. And then, of course, reason sets in and you know that you're cheating somehow, your model's all messed up, it's not actually learning anything because you've added in a feature. I mean, for us, it's like, or for Netflix, maybe if you're trying to guess whether someone watched a movie or not, if they rated it, yeah, they probably watched the movie. Maybe you're trying to predict chat and you say, oh, will this person ever talk to this other person? And you add a feature like the number of times that they've talked to each other. Or I think the one earlier was predicting pancreatic cancer, and the feature was, did you have pancreatic cancer surgery? So yeah, we know that there are features that you can't use in your model. This is already a human influence into the model in some sort, right? We have to be involved in this process. We know that not all features are necessarily useful. When we're doing ranking, for example, which is a problem we run into a lot. So for this user, what are the meetups that they're most likely to join? If we put in features that are purely about the user, and we're not doing a model that can do higher order sort of crossing features like logistic regression, it doesn't matter if the model gets more accurate. The ranking doesn't change at all, right? Does that make sense? And I loved Claudia's example about clicking on an email. The thing about predicting things is it's hard because it hasn't happened yet, right? This is a classic quote here. Claudia's example earlier was about clicking on an ad, and how if you teach your algorithm to guess if someone clicks on an ad, you might not actually do much good for the person that's paying for that ad, right? Offline performance is not guaranteed to predict online performance. I think the eBay guy mentioned how they were doing fancier models and it increased their offline error, or it decreased their offline error, but didn't have any effect on the actual business. This happens all the time. So the decisions that we're making about our models are already something that's in play all the time. That you can't just throw everything at the computer and let the computer make all the decisions. Especially in the context of something like a recommendation system, predicting the past behavior of something is not the same as influencing the behavior that you're trying to influence. So an ad is trying to get someone to buy something. A recommender system is trying to get you to watch a movie or a book or whatever. So at this point, I like to quote Pablo. This is Pablo Picasso. He said, "Computers are useless. They can only give you answers." And not that I think computers are actually useless, but I think he brings up a really interesting point here. We need to ask the right questions. And computers are getting so good at answering the questions, and obviously there's still work to be done there, but for practitioners, for people working at a company, for the most part, we're not designing new machine learning algorithms and stuff. The truth is we just have to think of the right question to ask. What is the variable we're actually trying to predict? I think even the reinforcement learning stuff is just a really interesting application of asking the right question, and you still have this problem of what is our efficiency marker that we're trying to predict here, or that we're measuring ourselves against. Value-added machine learning is a thing that I've been thinking about a lot. I heard about it at Rexus last year, and people are doing things like adding in factors of how much money do we make off of a click or a watch into their algorithms. So not just predicting what are you most likely to watch, but what are you most likely to watch and will make us the most money. That's what Netflix does, by the way. That's why all your recommendations suck. Okay, they don't suck, but they're pretty good. But the good stuff is hiding because they want you to watch the stuff that's cheap for them to show you, right? If they can get you to watch something that costs them less, they're probably going to do that. So hopefully nobody in here is from Netflix and wants to beat me up now. At Meetup, we're working on this because we recommend groups to people. Groups have events, right? And if you join a group, but then you never go to that group's event or any of that group's events, you don't actually get any value out of that meetup. So we're trying to work it into our algorithms where we can predict the likelihood of a join, which is the immediate action we're trying to get you to do, but to also take into account this future value of actually joining the group. And so if we just predict that you'll join, we can just predict that you'll join popular stuff, that you'll join things that match your interests, but that group might totally suck, it might never have events, everybody who goes might hate it. So what we want to do is figure out a way to account for the long-term value of that group and predict that instead. These are human decisions that are going into the algorithm. Another question that people would ask me a lot when I talked about not making racist computers was, oh, how do we get the computers to do this for us? How do we take that decision out of our hands? And there's something interesting there. Like I said, this Florian Tramer made this fair test algorithm. It's really cool. You can put it against your model, and it'll tell you whether you're accidentally using features that you didn't mean to use. So features that if your model is correlating with, for instance, someone's gender, you're actually treating men and women differently, even though you didn't know that you had men and women in your model. But on the broader hand, even if we have really good tools for doing all this, we still have to make the choice to make ethical decisions. We still have to decide which features aren't ethical. It was a really interesting post. I think this came out of Google. They talked about, those water bottles are going to fall. Nothing can be done about it. Sorry. They basically talked about this imaginary problem where you have two groups of people and you're trying to decide whether to give them a loan, and the two groups of people have the same mean, but they have different distributions. And if you model something that's unaware of the two groups, your optimal algorithm for profit is going to be biased against one of the groups. And I think the outcome they argued was that you should actually train separate models for the two groups And I think, it was model, this was very basic, it was like setting a threshold based on credit score, right? And they said, oh, what you should do instead is to set the threshold such that your false positive rate is the same for both groups, or your true positive rate, or one of those. I guess it's inverses, but anyway. I think this is a problem that doesn't really exist, though, right? Like, the problem with racial bias in our society isn't that, oh, the distributions are different, but the means are exactly the same, right? So we have to take a broader outlook on what can be done about this. And I think part of the mistake here is assuming that we can solve this entirely with math. We know that there are questionable real-world applications of machine learning, screening job applications, predicting someone's salary. Certainly, if you use past salary data and you include gender in the model, it's going to predict that you should pay women less than men, which is messed up. We know there's features that you shouldn't use, like race and gender and age. We also know that some of these things are totally illegal to do. So there's actual, formal constructs in our society to tell you that you can't do these things. But we also know it's unfortunately easy to accidentally do these things. So even if you don't directly include gender in your model, someone's first name is going to be highly predictive of their gender. Someone's name is going to be very predictive of their age. Names peak at different times, so you can guess if someone named Evan, they were probably born in after me. Evan peaked after I was born, but there's so you can imagine names that are only grandpas have. So that tells you if you use name, you're going to get age out of it for free, I guess. Certainly someone's graduation year, if you're not supposed to use someone's age in deciding if they're good for a job, that's a real problem. Someone's zip code is going to be highly correlated with their socioeconomic class because of the way that people are grouped together in the world. Claudia also talked earlier about how Facebook likes can be completely predictive of age. They can also be predictive of gender, I think, but I'm sure they're also predictive of age. I've seen myself there was an article once about using Facebook. It was like this very dystopian article. Facebook can predict if you're gay based on your Facebook likes. And then they had the list of the top 5 likes for gay men and for gay women. And the men, it was like musicals, and the women, it was like the TV show The L Word. And it's like, yeah, of course Facebook can guess that you're gay if you're a dude who likes musicals or if you're a woman who likes The L Word. But if you're going to put these likes or anything that's a proxy of this into your model can accidentally be biased towards these things that you might have never thought that it would have been. So I got to admit here, the very application that I built was doing this for years until I finally found out and fixed it. On Meetup, you can register for certain topics, and we use the topics to give recommendations and stuff like that. And there's a feature on the site where if you create a Meetup group, you can set the topics of the group. And we were showing women who were trying to start women business owners meetups, if they clicked on the women business owners topic, we'd suggest these other topics like crafts and fashion and style and skincare. These are like very stereotypically female interests, whatever. Now, of course, this is totally defensible. This is based on a basic collaborative filtering algorithm that's using user interests, and so women that are into these topics are more likely to be in these other topics. This is a totally true thing that's appearing in our data. But is it right for our application, and specifically this application within our product? And we decided that it was not. So it was actually an interesting thing to think about. This was a case where we were really asking the wrong question. And so what we were doing is we were trying to predict what other topics a person might be interested in. And we were using that to suggest topics for their Meetup group. But what we really should have been doing is using the topics of Meetup groups to predict what topics should go on Meetup groups, right? So we just got switched around. And so once we made that switch, we saw that somebody creating business meetups, whether they're a women's business meetup or just a regular business meetup, are going to get business topics and not these other stereotype gender suggestions. The point of all this, the thing I'm trying to get at is, well, I tried to show earlier that not everybody's going to necessarily agree with this. There are going to be some people at your work who think, oh, we can't sacrifice performance, we can't sacrifice the truth and mathematical beauty of our models to make these ethical decisions. And I think that that's kind of a bunch of bullshit. There's a bunch of decisions that we're already making in all of our models as data scientists and machine learning people or whatever. And not everyone's going to have the same ethical values, but when it comes into that argument, if you're at your work and you're trying to pick a side in this, I don't think you have to necessarily sit down for the argument that, oh, that's not optimal, or that's not true, that's not, you know, mathematically justifiable. This is an old piece of wisdom in statistics. All models are wrong, but some are useful. Your model's already biased. Your model's already wrong. It'll never be perfect. Don't let this old wisdom become modern heresy. That's it. Thank you.